we want to state the natural domain for each of the following rules. The first one is we have f of x is 3x minus 2. This is a linear function. Now remember, the natural domain is the largest set of values that can be input into the function. There's no problem with linear functions. If we think about 3x minus 2, there's no value of x that cannot be substituted here, and therefore the natural domain is all real numbers, and that's always the case for linear functions. In a similar way, there's no problem with any real value being substituted in here and then squared. So x belongs to the reals is the natural domain for f of x is x squared. Now we've met root x before. We should know what the graph of this looks like. It starts here at the origin and then has this type of shape, and it goes off to infinity along this way, but remember it starts just here. Now why does it start there? Well, we can't take the square root of negative numbers. You can take the square root of 0, you can take the square root of any positive number. So in this case, x is a real value, can be input to the function, but only if x is 0 or more. Now, f of x is 1 over x. Think about what we're not allowed to divide by. You can never divide by 0. So every real value is okay here except for 0. So we have x belongs to the reals. X is not equal to 0. If you think about 1 over x, and again it's a graph we know well, we have a vertical asymptote at 0. And that's because we cannot input x equals 0 into the function. Now this one here, the square root of 3x minus 2, is going to be similar to this one here. What we can't have is a negative inside here. So it only works if 3x minus 2 is greater than or equal to 0. So 3x needs to be greater than or equal to 2, so x needs to be greater than or equal to 2/3. So we can input any real value provided that x is greater than or equal to 2/3. Now this one is similar to this one. We're not allowed to have 0 on the bottom. How would we get 0 on the bottom here? Well, x plus 3 equals 0 if x was equal to negative 3 add 3 being 0. So here we can input any real value provided that x is not negative 3. Now let's think about this one. Again, we're only allowed 0 or positives under here. X squared plus 3x plus 2 equals 0. Let's solve that. We can do this one by factorizing. So x and x, 2 and 1, plus and plus. So x is negative 2 or negative 1. Now x squared plus 3x plus 2 are positive x squared, so we know it's this way. So if I were to actually sketch y is equal to x squared plus 3x plus 2, that's going to come like so. So this one is y equals x squared plus 3x plus 2. So we can input any value of x into here this way from negative 2, because that means that x squared plus 3x plus 2 would be positive. We can see that because the curve's above the axis. We could input any value from here, but we can't put any value of x between negative 2 and negative 1 in, because then x squared plus 3x plus 2 would be negative, and we can't take the square root of a negative. So here we'd have x belongs to the reals, where x is less than or equal to negative 2, or x is greater than or equal to negative 1. Now there are other ways of expressing this, using the union instead of or and so on, but don't worry about that too much. Now on the bottom here, we're not allowed to have the value 0, and as we saw from here, x squared plus 3x plus 2 is 0 when x is negative 2 or negative 1. So here we can input any real value, provided that it's not equal to negative 2 and not equal to negative 1.